Hello viewers, welcome to my YouTube channel. It's your number one tutor on this channel, the Science Demystifier. In today's video, I'm going to be showing you how to prepare a standard solution. It has been a pretty long while since we met on this channel. That was October last year. But because of the numerous calls I've received from people, asking me to show them how to prepare standard solutions, so I thought it wise to make this video to demystify the process. All right, now let's look at steps you need to take while preparing a standard solution. The first one is what you need. What you need. Now, the processes needed for the preparation of a standard solution include: one, volumetric flux. If you have a pen, you can write it down. Volumetric flux. So the volumetric flux comes in different sizes. We have 1,000 ml capacity. We have the 500 ml capacity. We also have the 250 ml capacity. Okay, whichever one you choose to use. Now, the next thing you need to prepare a standard solution is a petri dish, with which you used to do what? Measure your solids. With the petri dish, you measure the mass of the solids. We also have the stirring rod. So this is the stirring rod. So use this to stir the solution while you're mixing it. Okay? So you might need a beaker. Or a measuring cylinder. Okay? Now you also need an electronic weighing balance. In some other places, it comes in analog form. In some places, it comes in digital form. So it depends on the one you have in your laboratory. So you need an electronic weighing balance. Okay, now the next thing we need to consider here is how to avoid errors while preparing a standard solution. How to avoid errors while preparing a standard solution. One, please make sure that your instrument, that's the weighing balance, is highly sensitive. The sensitivity of your instrument is very, very key to preparing what? A standard solution. So don't just go out there and grab any weighing balance you see and then you use it to prepare your solution. No. You need an instrument that is highly sensitive. Now, the next thing you need to do to avoid errors is to wash your apparatuses. Please rinse with soap solution and distilled water before you use them. Okay, rinse with soap solution and distilled water before you use them. Okay, so the next thing here is use distilled water and not tap water. Don't say because you don't have distilled water in your lab, you want to improvise, you want to use tap water in the place of this. No, it is not done. Remember that distilled water is called deionized water. So what it means is that it does not contain any metallic ion. It doesn't contain dissolved salts. Unlike tap water that contains some metallic ions in them, and it contains also dissolved salts. Okay, so use distilled water to avoid adulterating your solution. Now, the next thing you need to know to avoid errors, or you need to do to avoid errors, is that compounds like alkalis, like potassium hydroxide, calcium hydroxide, sodium hydroxide, they are deliquescent in nature. These substances, when you expose them in the atmosphere, they absorb moisture. So definitely, when you want to prepare a solution of a base or an alkali, you don't expose it. Immediately cover it. Even when the compound is still in solid form, yet to be dissolved in water, make sure that it is well covered so that it does not pick moisture from the atmosphere, and that will lead to erroneous results. Okay, now the next thing you need to know is observing the meniscus from the base. Water forms a concave meniscus when it is in glass, as you can see. So water forms a concave meniscus. Why? Because the force of adhesion of water to glass is greater than the force of cohesion between water molecules. So that's why we have this water depressing in the middle, which is what we call the meniscus. So when you want to take your reading, it must be from the base of the meniscus. Okay? All right. Now let's go to illustration now. So this is what I'm going to show you how to go about preparing your standard solution. Now the first thing is to weigh the exact mass that was stated in your specimen paper. For example, just like last year, we were asked to measure 4.95 grams of sodium hydroxide. So that is when your weighing balance comes in. So you need to get a sodium hydroxide, weigh it, get exactly 4.95. So this is an already weighed solid, caustic soda. Okay? So this is 4.95 grams of caustic soda. So the first thing I will do is to dissolve this 4.95 grams of caustic soda in any volume of water, or distilled water. Any one. Okay, you can see this one here. So this is a given volume of water. So I will first of all dissolve the salt, I mean the compound, dissolve it in any given volume of water, and then with your stirring rod, you stir. Okay? Stir. Ensure that the salt is completely what? Dissolved. That's why you need to stir. Okay? So to have a homogeneous solution. Okay, after this, okay, you can see the salt has completely, the compound has completely dissolved. Then the next thing you need to do is you will pour the mixture in your volumetric what? Flask. So here I want to use the 1000 ml capacity, okay, so that I will have my solute in 1 dm cube of the solution. Okay, so you pour the mixture. Okay, so I have it here. Then the next thing you need to do, remember that some liquids are still here, so you need to add more distilled water to rinse the beaker. Add more distilled water to rinse the beaker. Then you pour again into the volumetric flask. Pour again into the volumetric flask. Pour again into the volumetric flask. Good. So you shake vigorously. Then the next thing I need to do is, remember that there is a mark on the stem. You can see the mark. So there's a mark on the stem. So I will use the distilled water to add up until when I get to this mark, I will stop. So this mark gives exactly 1000 ml or 1 dm cube of the solution. So that's what I'm going to do now. So pour the solution and the water into the solution until I get to the mark on the stem. So pour. Be careful when we are pouring. Please, at a point, you need to use your aspirator bottle, okay, so that you'll be adding the water little at a time. So I'm thinking that an aspirator bottle. When I say aspirator bottle, this is what I'm talking about. So this is what I'm talking about. So you need this. So with this, you can add the water little at a time until you get to the mark. Until you get to the mark. All right. Okay, so be careful as the level of the liquid approaches the mark. You need to slow down. You need to slow down. Okay, I'm almost there. Almost. Okay. Good. I have it. So this is exactly 4.95 grams of caustic soda in 1 dm cube of the solution. In 1 dm cube. I didn't say 1 dm cube of water. Please, it is not 1 dm cube of water as people always say. It is 1 dm cube of the solution. Okay, so now the next thing we need to learn is how to express the concentration of the solution that we have just prepared. Now the unit of concentration can either be in gram per dm cube or mole per dm cube. For example, I dissolved 4.95 grams of caustic soda in 1 dm cube of the solution. So I have 4.495 gram per dm cube, which is what we call mass concentration. Now this mass concentration can be changed to molar concentration. It's very easy to convert from mass concentration to molar concentration. All you need to do is divide the mass concentration by the molar mass of the compound you have prepared. That's just it. Now, since the compound I prepared here is sodium hydroxide, all I need to do is to divide the 4.95 grams per dm cube by 40 grams per mole, because that's the molar mass of sodium hydroxide. And that will give me the value in mole per dm cube, or the molar concentration of the solution. All right, so this is where we are going to draw the curtain on today's lesson. I am promising you in our next video, I will be giving you an explicit calculations that is titration based. Okay, so please don't forget to subscribe to this channel. Please, I beg you, don't forget to subscribe to this channel, and also touch the bell notification. Click on the bell notification so that you will get our video updates. Thank you and God bless you.